In this video, we are going to discuss about the resistance temperature detector. So by the end of this topic, the students will be able to understand the foundational physics of temperature dependent resistance changes in conductors. They can able to analyze the mathematical relationships, evaluate the material characteristics of common sensing elements like copper, nickel, platinum, and discuss how these linear properties are used in the is used for accurate thermal monitoring in biomedical as well as clinical instruments. So the functional operational principle of RTD is actually quite elegant. The electrical resistivity of a sensor changes when its temperature is altered. So when we actively utilize this property to perform the high accuracy temperature measurements, this will be suitable for most pure metals. So the variation in the resistance R with the absolute temperature can be mathematically expressed. You can see the relationship here. So in this expression, R0 is denoting the reference resistance at the baseline temperature and the T is equal to 0. So it represents the material specific constants, and this practical realization of this is the industrial platinum resistance thermometer will relies on the fine platinum coil or film to accurately track the thermal changes based on the electrical shift. So when we perform a close examination of the resistance versus temperature, performance curves will form across the various metals. We can notice that an interesting structural trait, that is, the curves are very linear. In fact, when we constrain our operations to relatively short temperature spans, this linear behavior will become more significantly evident, and this simplifies our data acquisition and signal conditioning requirements, as the higher order non-linear terms in our polynomial equation is living with a high stable and direct relationship. So to utilize this clearly, it is the straight line mapping should be simplified here. So here we can compare the primary metals used in the RTD manufacturing by looking at this relative resistance versus temperature characteristics of copper, platinum, nickel and Balco. That is, it becomes immediately clear that platinum maintains a beautifully linear relationship across the expensive temperature range, that is up to 1000 degrees Celsius. So this exceptional stability is precisely why, because the platinum is universally preferred as the premium material for precision temperature sensing elements, which can be used in the critical engineering as well as medical diagnostic instrumentation. Thank you.